Alright, lesson 9.4, working with formulas, which is what we're going to do a lot of in math. We're going to have different formulas, but some of them are going to kind of pervade throughout all your classes, like interest, distance, rate, time, stuff like that. So it's kind of good to kind of start learning a little bit of them now so that we kind of get into our lexicon. Okay, we're going to solve the applied problems by evaluating known formulas at given values and variables. Okay, and then we're going to solve those formulas. Okay, note, be sure to use letters just as they are given in the formulas. Okay, it's very true. Don't start making up your own letters. Okay, these letters are there for a reason. Keep them so that way you kind of memorize it in the form that they are needed. Okay, let's look at the first one here. Example 1, application evaluating formulas. A loan for a period of 1 year or less is called a note, and the interest earned or paid is called simple interest. Okay, a note involves only one payment at the end of the term of the note and includes both principal and interest. The formula for calculating simple interest is interest equals principal times rate times time. Okay, continue that onto the other page here. Note the rate of interest is usually given in percent form and converted to decimal form or fraction form, okay, which we will kind of get into. Continue on here. Okay, Maribel loaned $5,000 to a friend for 3 months at an annual interest rate of 8%. How much will her friend pay her at the end of 3 months? Okay, well, let's remember our formula that looks like. They're not really showing here. Are they showing it maybe on the next page here? Yes, they do show it on the next page. So let's start looking. The principal, Maribel loaned, okay, is going to be this right here. The rate, 8%. And then how long is 3 months? Well, notice what they did here. They said there's 12 months in a year, so she did 3 out of 12, okay, out of a year. So that's a quarter of a year. So that's our time, okay? Yeah, you could do it by 3/12, but go ahead and simplify whenever you can. Let's come here. Find the interest. Okay, well, notice what we do here is we're going to do the interest. They plug everything in here. Let's kind of come in here. I'll kind of highlight as we go along. Here. So here's going to be our principal, and then they do the 0.08. Remember, that's how that is the interest. That's percent, okay, as a decimal, which is how you're going to want to do this, okay. You also probably have a percent button on your calculator, okay. So we got 0.08 multiplied by 1/4. Okay, that's going to give us this 5,000 times 0.02, which is going to be 100. So the interest after 3 months, okay, is going to be $100. And the amount to be paid at the end of 3 months is the principal plus the interest. So that means she's going to have to pay back the $5,000 plus the 100, and so that's going to give her the $5,100. All right, let's continue on. Let's look at another one here. Okay, we've got the formula. Given the formula, Celsius, okay, that is Celsius right there, is equal to 5/9, well, multiplied by F minus 32. Well, first, find C if F equals 212, okay, 212 degrees Fahrenheit, and find F if C equals 20, okay. Well, they're giving us two different things here, so let's kind of start breaking it down. So for this first part, we're going to take the F and plug it into the equation at 212. So let's find out what that is. Okay, let me get my pen out here, and we've got C is equal to 5/9. Okay, well, instead of this F, we're going to do 212. Okay, minus 32. Okay, let's do 212 minus 32. And we get 180. So we get C is equal to 5/9 times 180 over 1. And you can, technically speaking, you can go and start reducing. If you're going to use your calculator, you can go ahead and do the 5 times 180. Okay, that's going to give you 900. And then divide that by 9. Okay, and of course you get 100. Okay, so if something's 212 degrees Fahrenheit, it's going to be 100 Celsius. Okay, very simple. Okay, well, now let's find it. What if C equals 20? Celsius equals 20 degrees. Well, let's do the problem the other way now. We're going to go ahead and have Celsius equal 20. Okay, all equal to what? Well, we got this 5/9, and we still have the, now we don't have an F anymore. Okay, now we got a half F of minus 32. Okay, well notice I've got a fraction here, so I can go ahead and multiply this 9 over, okay? Because I've got division happening, so I can multiply everything by 9 over 1, and what I do over there, I have to come over here and do. Okay, well notice here, that is going to reduce out my 9 off this side, which is great, that's what I want. Okay, then I got 9 times 20, which is going to give me 180. 20, double check. I always double check with the calculator. It's kind of like a muscle memory thing, I guess, from taking too many math tests. So then I have 180 equals 5, okay, times F minus 32. Well, notice now I've got this 5 times. So let's go ahead and divide off this 5 off both sides. Well, that reduces out, and I get 180 divided by 5, and I get 36. Okay, so now I have 36 equals F minus 32. Well, notice that's a F minus 32, so let's go ahead and add 32 to both sides, and our final answer is going to be F is going to be equal to 68 degrees. Sorry, make that better. Fahrenheit. So, whenever it's 20 degrees Celsius, it's kind of a comfortable 68, maybe 68 degrees outside. I mean, some people might not find that as comfortable as others, but I find that to be pretty comfortable. So, but also though, if it's a 212 degrees, if you're boiling water at 212 degrees, well, water boils at 100 degrees Celsius. So let's continue on. Alright, example 3 application. The lifting force F exerted on a plane's wing is found by multiplying some constant K by the area A of the wing's surface and by the square of the plane's velocity V. The formula is F equals KAV squared. Find the force. Okay, here's where we got to start paying attention. Find the force. They're telling us to find the force, so we don't know F. Okay? On the plane's wing during takeoff, if the area, well, area is going to be the A, so let's go and start plugging everything in. A. Okay, so I've got A. Second here. My area is going to equal what? 120. Well, I know that part now, so that guy's good. K, my constant, the guy that never changes, okay, he's going to be equal to 4/3. And then the plane is traveling at 80 miles per hour during takeoff. Well, that's going to be my velocity. So velocity is going to equal 80, but not just 80, 80 squared. Okay, so we can take all this and we can plug it into our equation. Okay, so we've got, let's see, rewrite this real fast. I have force equals, I think it's K times A V squared. Okay, well, let's start. We're looking for the force, and that's equal to the, well, the K was the 4/3, and then our A was, I believe, yes, our A is 120. So let's multiply by 120, and then our V is going to be the 80 squared. Well, 80 squared, we can put this up on the calculator, 80 squared is going to be 6,400. So we can rewrite this as F is equal to 4/3 times 120 times 6,400. And we just throw everything into the calculator, do 6,400 times 120. Okay, 6,400 times 120 is going to give me 768,000. Okay, and we can multiply that by 4. Okay, and then divide that by 3, and we get, okay, our force. Remember, this is all calculator. Okay, I'm going to put that here. Just put all calculator. Later. Okay, come in here and just write this as the force is equal to 1,024,000 1,000, okay? Well, the force is in pounds, okay? That is the amount of force, okay, being applied to the wing right there, okay? Well, actually kind of amazing if you ask me. I mean, that's just amazing the amount of force being applied to that. So let's continue on with another example here. Let's look at the perimeter of a triangle. The perimeter of a triangle is 38 feet. One side is 5 feet long. The second side is 8 feet long. How long is the third side? And notice they're using the formula P equals A plus B plus C. And then we're substituting B for 38, A 5, B for 18. We can come over here. I believe they already have this drawn out for us. Yes, notice we've already got everything here. So I can come right in here and plug everything into our equation. Very simple one on this one. We have P is equal to, well, A plus B plus C, which they say right here. My P is going to be 38. Okay, my A is 5. My B is 18. And then do I have a C? No, I just have this. So here I'm going to have 5 plus 18. That's going to give me 23. So I'm going to have 38 equals 23 plus C. We can subtract off 23 off both sides. And notice whenever we do that, we're going to get C is equal to, well, 8 minus 3 is going to be a 5. And 2 from 3 is going to be 1. So our C is going to be 15. And do they give us any sort of unit? No. So pretty straightforward and simple on that one. Okay. And then looking here, we can look at this real fast. Given the equation 2x plus 4y equals 10, solve the equation in terms of y, and then solve it in terms of x. This is going to be something you're just going to have to learn to do. Okay, pretty straightforward. Notice when it says solve for in terms of, okay, solve for x, okay, in terms of y, then solve for y in terms of x. Okay, it's just a point of getting something alone is all we're going to be doing. So what we'll do here is we'll get the first one alone by itself. And so solving for x first, okay, so solve for x is get x by itself. So let's subtract off the y. So let's come in here and rewrite. Okay, we've got a, okay, we got 2x plus 4y equals 10. Let's subtract off the 4y off both sides. Okay, then we've got 2x is equal to, well, that's going to give me a negative 4y plus 10. Then we need to go ahead and divide off the 2, and I'll divide off amongst everything, and that's going to give us x equals negative 2y plus 5. Okay, well, that was solving for x. Now let's just solve for y. It's going to be the same process. Let's solve for y here. We're going to have 2x plus 4y equals 10, but now I'm going to subtract off the 2x off both sides. That's going to give me 4y equals, I've got negative 2x plus 10. Divide off the 4. Okay, well, notice here I'm going to get some fractions, but that's fine. I've got y is equal to, well, that's going to be a negative 1/2 x. And then here we're going to have plus 5/2. And that would be our final answer for that one. And works out really nice. Okay. Notice here you can also keep the x on top if you like, but we'll do some Hawks examples, and it's really up to you. I like that. To me, sometimes that looks a little bit cleaner.